All right, so we are in question number 111 of physics workbook solution. Okay, so if today is your first day of watching, please subscribe. So this question said a disk accelerates uniformly from rest to an angle to an angular speed of 400 rad per sec in 2.50 seconds. Let's say calculate the what? Angular acceleration. Okay? We should calculate the angular acceleration. So we need to know that normally V is equal to U plus AT. Okay? So angular acceleration is what? Angular velocity is equal to initial angular velocity plus what? Acceleration times time. So I have what? 0 plus what? Okay, so this one, angular speed they gave me is 400 is equal to 0 plus my alpha is unknown, and then the time is 2.5. So I have that what? 2.5 alpha is equal to 400. So alpha will now be what? 400 divided by 2.5. So I'm going to have 400 divided by 2.5 will give you 160 in rad per second square. Okay, so that is that. We move to question number 112. Question number 112 says state the second law of motion. Okay, write that in my comment section for me. Okay, so let's go to question number 113. Just state the second law of motion. So write it for me at the comment section. So 113 said a force of 200 Newton pulls a block of mass 50 kg and overcomes a constant frictional force of 50 Newton. Okay, they now say what is the acceleration? What is the acceleration of the body? Okay, solution. Now the force applied is 200 Newton. The force applied. While the frictional force is equal to what? 50 Newton. So the resultant force will now be what? The force applied minus the frictional force, which is equal to what? 200 minus 50, which is what? 150 Newton. Okay, so they say we should calculate the acceleration. My R will now be MA. So my A will now be the R over M. So which is what? 150 divided by the mass they gave me there is 50 Newton. 50 kg. So 150 divided by 50. Question number 113. 150 divided by 50 have 3 meter per second square. So that is that. So we move to question number 114. Question number 114. So for question number 114, question number 114 said at what respective values of x, y, and z would the unit of force Newton be dimensionally equivalent to m raised to power x, l raised to power y, t raised to power z. Okay, solution. Force, I know that force is equal to what? Ma, which is what? Mass times acceleration due to gravity is what? Meter per second square. So if you equate this thing to my mx ly tz, you will now see that x is equal to what? 1 is here. My y is equal to another 1 is here. But my z is equal to what? -2. So that is the value of that. So go to question number 115. Question number 115. Question number 115. 115 said the mass of a load is doubled while the force acting on it is halved. Okay, the resultant acceleration of the load will be dash. Okay, solution. Now what do we do? First of all, let the initial mass be mu0. mu0 is the initial mass. The initial force is F0 and the initial acceleration is A0. Okay, so and we know that what am I saying? Question number 115. Okay, and then the new force, the new mass, which is mu1, which is what? Double of that mu0. Okay, the second force will now be what? Half of the first force. But I know that my F is equal to what? F is equal to MA. Okay, so what are they asking us? So they're asking us our A. If F is equal to MA, that means, okay, let me say F1 is equal to M1A1. We know this. So now, but my F1 is equal to 1 over 2 F0. So 1 over 2 F0 is equal to what? My M1 is what? 2 M0. My M this is what? My A1 is unknown. My A1 is unknown. So my A1 is unknown. So if I make A1 subject of the formula, I'm going to have that, what am I saying? Yes, if I make one subject of the formula. So, but F0 is same thing as what? F0 is same thing as what? M0A0. So let me put it there. M0A0 over 2 is equal to what? 2M0A1. So I want to make A1 subject. So if I want to make A1, so A1 will now be what? M0A0 all over what? 2 times 2 M0. So M0 take care of M0. I'm having 1 over 4 A0. So the acceleration will now be 1 over 4 of the initial acceleration. So that is that. So move to question number 116. So question number 116. Question number 116 said an object of mass 200 gram projected vertically from the ground level has a velocity of 10 meter per second. Has a velocity of 10 meter per second at a height of 20 meter. Then I say calculate the initial kinetic energy at the ground level. Okay, solution. Look at what they gave us. They gave us mass M as what? 200 gram, which is what? 200 divided by 1000, which is 0.2 kg. Okay? So they gave us velocity as what? 10 meter per second. We know that kinetic energy is equal to what? Half mv squared, which is what? 1 over 2 times 0.2 times 10 squared. So which is what? 0.5 times 0.2 times 100. So I have 10 joules. So I have 10 joules. Okay, so question number 117. Question number 117. So question number 117 said, question number 117 said, a planet has mass m and is at a distance r from the sun. Another planet has mass m and at a distance of 2r, okay, distance of 2r from the sun. Then I say determine the ratio of the gravitational forces experienced by the planet. Solution. Okay, I know that my F is equal to gmm over r squared. Okay, but this is equal to what? Mg is equal to what? Gmm over r squared. So this take care of this. I'm going to have that my g is equal to what? Gr squared over m. Okay, so let's call it 111 is equal to what? Gr squared over m. 222. So the g there are the same. Okay, sorry. We are looking for the ratio of the other g. So I'm going to have that my small g is equal to what? Gm over r squared. 111 is equal to what? Gm over r squared. 222. So let us put everybody. So I'm going to have my g. So I have g1 over g2 will now be, if this one come down, this one go up. So I'm going to have m2 r1 squared all over m1 r2 squared. So m1 and m2 are equal, they cancel out, but my r1 is r1 squared, okay, all over my r2 is 2r1 all squared, which is what? R squared 1 over what? 4r squared 2. So 4r squared 1. So I'm going to have that g1 over g2 is equal to what? 1 over 4. So which is what? G1 is to G2 as ratio is 1 is to 4. Okay? So that is that for that. So go to question number 118. Question number 118. M1 is equal to M2. That's why they cancel out immediately without substitution. Okay? So go to question number 118. So question number 118 said, let me change this to 4. Question number 118 said the distance comma, x meter. X meters traveled by a particle in time, comma, t seconds is described by an equation. X, which is equal to 10 plus 12t squared. We now say find the speed. Find the speed. Find the speed at time t, which is equal to 2 seconds. Okay, solution. So they gave me that x is equal to 10 plus 12t squared. Okay, so you should know that speed is what? Change in distance over what? Time, which is what? This differentiation of this is 0. Differentiation of this is 24t. Okay, so now at t equal to 2, I'm going to have that speed is equal to what? 24 in bracket of 2, which is what? 48 meter per second. Okay, so 119. So question number 119 said a ball is kicked into the air at angle of pi over 4 radian to the horizontal with a velocity of 80 kilometer per hour. Then I say neglecting air resistance to the ball. And I say calculate the total period of flight of the ball. Solution. So let's get our parameter. The first thing they gave us was theta, which is pi over 4. Don't forget that pi in terms of angle is 180. So 180 divided by 4, what do you have? Question number 119. 180 divided by 4 will give you 45 degrees. So the next thing they gave us is our u, which is what? 80 kilometer per hour, which is what? 80 times 1000 divided by 60 times 60. So which will give you 22.22 meter per second. So I know that my period is equal to what? 2u sine theta over g, which is what? 2 times 22.22 times sine 45 all over what? 10. So do that and get your final answer. So we'll move to the last question for this video. The last question for this video, which is question number 120. Question number 120 said, given the position of a particle of x, which is equal to 10t minus 12t squared plus 5t cubed, where x is in meters and t in seconds. Then I say calculate the velocity of the particle at t equal to 3 seconds. Okay, solution. The same method again. So we have that our x is equal to what? 10t minus 12t squared plus 5t cubed. So you tell them that speed is equal to what? Change in distance over change in time, which is 10 minus 24t plus 15t squared. Okay, so that's how to differentiate. Multiply by the power, remove one from the power. So then you now tell them that at t equal to 3, your speed will now be 10 minus 24 into 3, then plus 15 into 3 squared. So I have 10 minus 24 times 3. 24 times 3 will give you 72 plus 135. So if you do everything, you're going to have 73 meter per second. So thank you very much for watching. Please don't forget to like, share, and subscribe. Bye bye.